Alright, next up we've got objectives 55 and 56, which is adding and subtracting radicals. Before we talk about adding and subtracting radicals, let's talk about adding and subtracting variables like x and y. So here I've got an expression. In order to simplify this expression, we combine like terms. So again, we look for the same variable with the same power. So here we've got 5x and 8x. What do we do with these? We add the number in front. So we have 5 plus 8 gives us a 13x. Moving on to our next term, we have a negative 9y and a positive 5y. When we add those up, we have a negative 4y. And then we've got a positive 4 and a negative 2 gives us a positive 2. So this is our final solution here when we simplify this expression. Again, we look for the same variable and the same exponent, so all of these have exponent 1. And then we add the coefficients. So looking at this next one here, we've got, let's look at our a terms. We've got a negative 2a, a negative 5a, gives us a negative 7a. Looking at our b terms, we have an 8b, and we have a 9b. So that gives us a 17b, positive. We've got a negative 9c and a negative 4c, so negative 9 plus negative 4 gives us negative 13c. And last but not least, just a plus 9 at the end. So this is simplified here. So again, we're looking for the same variable, and then we add the coefficients. All right. So adding and subtracting radicals is really not all that different. Again, we're going to be combining like terms. So adding and subtracting radicals. All right. So it's quite similar. So it's just like combining like terms. And we'll talk about what are quote-unquote like terms using radicals. We can only add and subtract radicals when they have the same number and variable on the inside. So we can only add and subtract radicals with the same number or variable on the inside. Always simplify first. So anywhere you can, always simplify first. Why? Because it might allow you to combine more like terms. So it might allow you to combine more like terms. And last but not least, just like up here when we're adding the coefficients, we're not changing the variable, we're only going to add or subtract the outside numbers. The inside numbers stay the same. So the number inside the radical stays the same. Okay, so we combine like terms, we simplify first, and we only add or subtract the outside numbers. So let's try a few examples. This first one, I noticed that we've got a couple of root 5s and a couple of root 11s. So looking at this here, we're looking for terms that have the same radical, so the same number or variable on the inside. So here I see that we've got a root 5 here. So we can add or subtract the numbers out in front. So we have 2 plus negative 8. Gives us a negative 6. And then again, the radical doesn't change. The number inside doesn't change. Then we add our root 11s. The coefficient here, the number in front, if there's nothing written, you can assume it's 1. So we have 1 root 11 plus 3 root 11 gives us 4 root 11. So again, the number on the inside doesn't change. We add the numbers on the outside. And that's as simple as it gets. We can't combine these because the number on the inside of the radicals are not the same. So moving on to this one, here we have 5 root 3 and 8 root 3 gives us 5 plus 8 is 13 root 3. We've got a negative 9 root x and a positive 4 root x gives us a negative 5 root x. That's as simple as that one gets. Looking at this next one, we have 5 root 3 plus 48. We can't combine anything right off the bat because we don't have any radicals with the same number underneath. So we have to first simplify. So this first one, 5 root 3, we can't break down 3 anymore, so I'm just going to bring that down. 48, how can we break that down? We can say that it's 4 times 12. Again, you can choose any factors of 48. We'll continue to break that down. We have 4 can be broken down into 2 and 2. 12 can be broken down into 2 and 6. We can break that down even further. And notice each time I'm rewriting 5 root 3, just so that we don't lose anything along the way. So we have the 2 can be brought down, this 2 can be brought down, this 2 can be brought down. And then 6 can be broken down into 2 times 3. So using our jailbreak method, we pull out partners. So we pull out 2 pairs. So we have 5 root 3 plus, on the outside we have 2 times 2, which is 4. And then what's left over is 3. So now we have 5 root 3 plus 4 root 3. We've got the same radical, same number underneath the radical. So we can just add the numbers in front. So 9 root 3. And that's our final answer. Let's try one more. We've got 5 root 20. We can break that down into 5 root, and then we have 20 can be broken down into 4 times 5. And minus 6. 45 can be broken down into 9 times 5. We'll continue. 4 can be broken down into 2 and 2. We'll bring down our 5. We have minus 6. 9 can be broken down into 3 times 3. We'll bring down our 5. We pull out our partners, so we pull out a 2, so we have 5 times 2. And then on the inside, what's left over is just 5. For the next term, we have minus 6 times, we pull out a 3, and what's left over is just 5. 5 times 2 is 10, root 5. We have minus 6 times 3 is 18. And what's left over is root 5. And we have 10 root 5 minus 18 root 5. We can combine these. So the radical stays the same. We still have root 5. But then we have 10 minus 18 gives us negative 8. So again, always simplify first. See if you can reduce your radicals and then combine radicals that have the same number on the inside. All right, we're going to get some practice on this. So go ahead and review your notes and then we'll practice.